This problem asks us to graph another rational function by drawing all the key features on this plot. And this one is a cubic divided by a quadratic. Okay, I mean, this is a power of x cubed on top and x squared on bottom. And normally these things are not presented in both factored and standard form, right? You usually have to factor them yourself. But because this is such a complicated function on top, right, you would probably need the rational roots theorem to factor that. In an effort to make this problem a little simpler, I just presented it to you in both the factored form and standard form. Okay. Now, we're going to go through this list one at a time, and let's just figure out all these points. So, y-intercept first. Remember where that comes from. You look at the last terms in the rational at the very end, and you basically perform that ratio. So negative 24 divided by 4 is negative 6. So I'm going to come down here, use the dot button, and plot negative 6 as my y-intercept. Another way to think about this is when you find the y-intercept, we're saying x equals 0, right? So you just plug in x equals 0, and all these x's cross out, and all you're left with is negative 24 over 4. Okay? So that's the y-intercept done. That's one of the easy ones. Let's move on to x-intercepts. So with x-intercepts, remember what these are. These are factors on the top, which are not also on the bottom. And I see one right there, x plus 4. I see another one, x minus 4. But x plus 2 is on both the top and the bottom, so that's not an x-intercept. So we'll just plot the ones we have. There's x plus 3, and there's x plus, x plus 4, x minus 4. That's what I meant to say. X minus 4 goes over here. Okay, so that's the x-intercepts. Now the holes, let's talk about that one, because this does start to get a little complicated. The holes are factors which are on the top and on bottom. Okay, like this guy. So x plus 2. So we know the location is going to be at x equals negative 2, but we don't know the y location of that hole. And to figure out the y location, you have to plug the x location back into a simplified form of this equation, having removed the discontinuity. That's why it's called removable discontinuity. So we would say negative 2 plus 3 and negative 2 minus 4 divided by 2 times negative 2 plus 1. Okay, so just work that through. This is going to be 1 times negative 6 divided by 2 divided by negative 1, which is negative 6 over negative 2, which is 3. So the location of this hole is at negative 2, comma 3. And we can plot that using the open circle feature on this graph right here. So what was that again? Negative 2, comma 3. Okay, so negative 2, 3. That's going to be right around here. Okay. So this graph is really coming together. Let's move on and do some vertical asymptotes. That'll be a nice break. Vertical asymptotes, if you remember, are factors on the bottom which are not also on the top. And there's only one of those in this version of the equation. So I would use my line feature on the graph, that's this guy right here, and plot a line at x equals negative 1, because it is a vertical asymptote, going straight down like that. Next, we move on to the horizontal asymptotes. Well, is there even a horizontal asymptote here? Remember what you need. Horizontals need equal weight or bottom heavy. And this, if you look at the power functions, is a top-heavy equation. It's a higher factor of x on the top than the bottom, which means the horizontal asymptote does not exist. You don't need to draw it on the graph because it's not there. We need to move on to finding the oblique asymptote. And with this one, you can use synthetic division or long division. I prefer synthetic division. We've gone over both. Now the synthetic division. Here we go. So I'm going to take my synthetic division bar. I'm going to take all my coefficients of this top. 1x cubed, 1x squared, negative 14x, negative 24. And I'm going to divide it by one of the factors. Let's choose this one. Okay, x plus 1. So there's my negative 1. And we work through this. Should be pretty quick. 0, negative 14. And we don't need the remainders. Now you take that part and you divide it by whatever factor you didn't do the first time. So that's going to be this guy, negative 2. So 1, -2, -2, and we don't need the remainder. Okay. So even though we have to do 2 steps of synthetic division here, I don't think it's that bad because, well, it's just not. It's pretty quick. So we would say y equals x minus 2. However, we're not done yet because if you remember, take a look up here. There was a factor of 2 up front, which we ignored. And the synthetic division doesn't know about it, right? Synthetic division is just a hack. So you have to remember to divide by whatever that factor was. So in simplified form, this is going to be 1/2 x minus 1. And if you draw that on the graph, here's the -1 right here, and 1/2 x is a shallow slope that looks like this, roughly. I think I'm getting that about right. Okay, there we go. So there is our function with all its key features graphed. Now, if you're interested, when you're connecting the dots in a rational function, you just obey the asymptotes and dots, and this is what it would look like, right? We would have a function that kind of swoops through like that. And here, remember, it doesn't go through the dot, it crosses over it. So that's what our actual rational function would look like in black. But you don't need to draw that for this problem. All this thing is asking for is the intercepts, holes, and asymptotes.